Today, now my topics, myself Dr. K. Velayudham. Today present my topic glycolysis. What is the glycolysis? The glycolysis is the process of the result conversion of molecules of glucose to two molecules of pyruvic acid. The glucose is the 6-phosphate is the principal component of metabolism of glucose. The two major pathways of glucose 6-phosphate metabolism, one is from anaerobic glycolytic pathway, another one is aerobic pathway, anaerobic and aerobic pathways. Step 1. The phosphorylation. The glucose is converted into glucose 6-phosphate via the hexokinase. This is the irreversible reaction with the presence of ATP molecules and the activator of Mg++. And second step, the isomerization. The glucose 6-phosphate is converted into isomeric form of fructose 6-phosphate in the presence of enzyme phosphoglucose isomerase. And third step, the second phosphorylation reaction follows the isomerization. The fructose 6-phosphate is phosphorylated by ATP to fructose 1,6 diphosphate, and this reaction is catalyzed by the enzyme fructophosphokinase and the presence of the ATP molecules. And the fourth step, the cleavage of fructose 1,6 diphosphate. The reaction involves a splitting of fructose 1,6 diphosphate molecule between 3 carbon atoms and 4 enzyme hydrolase molecules. The split is of two compounds, namely glycerol deID3-phosphate and dihydroxyacetone phosphate. The catalyze the enzyme of hydrolase. It is a reversible conditions. And fifth step of the reaction of isomerization. The isomerization of glycerol deID3-phosphate on the direct pathway of glycolysis, but dihydroxyacetone phosphate is not. However, dihydroxyacetone phosphate, it can be really converted into glycerol deID3-phosphate as both are isomers. The glycerol deID3-phosphate is aldose and the dihydroxyacetone phosphate is a ketose. This is the isomerase is catalyzed by the enzyme trilose phosphate isomerase. And the reaction reversible at the two molecules of glycerol deID3-phosphate are formed from one molecule fructose 1,6 diphosphate. And finally, is the other step of the oxidation of phosphorylation. The step 6 is the oxidation of phosphorylation. The glycerol deID3-phosphate is oxidized and phosphorylated stimulously under the influence of enzyme glycerol deID3-phosphate dehydrogenase in the presence of NADP plus and inorganic phosphate to form 1,3 diphosphoric glyceric acid. The coenzyme NAD is a oxidized form and has the net positive charge and hence written as NAD+. When the glycerol deID3-phosphate is oxidized, NAD+ is reduced to NADH and one proton is released into the aqueous medium. And finally, this oxidation of phosphorylation. This reaction is significant with respect to energy transfer as the reoxidation of NADH to NAD+ by the electron transfer system can lead to the synthesis of ATP molecules. Normally, when electron flow from NADH through the electron transport chain, which occurs in the inner wall of the mitochondria, the 3 molecules of ATP are formed at 3 different sides of the electron transport chain. It's the one of the important of oxidation phosphorylation of this step 6. The glycerol phosphate shuttle, the NADPH, produced in the cytoplasm by the whole conversion of glycerol deID3-phosphate to 1,3 phosphoglycerolic acid cannot directly enter the respiratory chain as mitochondria are impermeable to both NADH and NAD+. Hence, instead of NADH, the electrons from NADH are carried into the mitochondria by a system of the operates between the mitochondria and cytoplasm known as glycerol phosphation, by the which each NADP molecule produces only 2 molecules of ATP instead of 3 molecules of ATP molecule. Now start step 7. The step 7 substrate level of phosphorylation. The high energy phosphate group 1, 3 diglycerate is transferred to the ATP, the resulting the formation of 3-phosphoglyceric acid and ATP molecules is released. The enzyme that catalyzes the reaction of phosphoglyceritic kinase in the presence of Mg++. The Mg++ is the activator of the equations. The phosphorylation, which occurs the step of substrate level, the phosphorylation, the construction process is respiratory chain phosphorylation, also called oxidative phosphorylation, which is the formation of ATP coupled to the oxidation of NADPH or FADH2 or by oxygen release. When high energy phosphate bond is formed directly. And step 4, the isomerization, the 3-phosphoglyceric acid molecule undergoes internal rearrangement to form up 2-phosphoglyceric acid. The phosphate group is transferred from 3rd carbon atom to the 2nd carbon atom. This reaction is catalyzed by the enzyme phosphoglyceromutase. In general, a mutase is an enzyme that catalyzes the intramolecular shift, the transfer of chemical group from one carbon to another carbon of same compound of the chemical groups. And the step 9, dehydration. The 2-phosphoglyceric acid is dehydrated by the reaction of the enzyme enolase in the presence of Mg++. The yield of phosphophenol pyruvic acid, which is a high energy enolopic phosphate group. And step 10, substrate level of phosphorylation. In the final step, the transfer of phosphate from phosphophenol pyruvic acid to ATP molecules. Thus, the molecules of ATP is directly synthesized and pyruvic acid is also formed. The reaction is catalyzed the enzyme pyruvate kinase. The yield of the glycolysis, how many ATP molecules? The net reactions in the transformation of glucose to pyruvic acid. The glucose into glucose 6-phosphate, the total of ATP gain 1 ATP loss. And fructose 6-phosphate to fructose 1,6 diphosphate, the ATP molecules loss. And third one is 1,3 diphosphoglyceric acid, 2,3 phosphoglyceric acid, the plus gaining from 2 ATP molecules. To phosphophenol pyruvic acid to pyruvic acid gaining from 2 ATP molecule are gained. The reoxidation of NADH plus 2H catalyzed by glyceraldehyde 3-phosphate dehydrogenase is a respiration is a 4 ATP molecules the gain. Our total is a net gain of ATP molecules 8 ATP molecules. The fat of the pyruvic acid. The various reactions is a conversion of glucose to pyruvic acid is a very similar in all organisms and in all kind of cells, but the fat of pyruvic acid in generation of metabolic energy is variable in different cells and different organisms, depends on the availability of oxygen. The pyruvic acid take up any one of the following routes: the conversion of pyruvic acid to ethanol, anaerobic conversion of pyruvic acid to lactic acid, oxidation pathway of pyruvic acid. These are all the glucose to pyruvic acids. The total number of ATP molecule gaining from 8 ATP molecules. Thank you.